analyze, improve, and control. And the aim of Six Sigma is to reduce the defects from our business process, right? Our business process produces products and offers services, and customer always expect defect-free products, defect-free services, right? Any non-conformance that is present in any product or any service is considered as a defect. And statistically, if you think deeper, you will understand variation is the root cause of the defects, right? The initial clue about whether a defect is going to happen or not, you can get the information by looking at the data. Otherwise, what happened, only at a later stage you come to realize that a defect has happened. So that's why I always say Six Sigma methodology is superior to any other methodology. Even before a problem can happen, you can predict that the problem is going to happen, right? And that's the advantage of equipping yourself with the Six Sigma concepts, tools, and techniques. And Six Sigma is all about defect reduction. Lean is all about waste reduction. Reducing the defects will make your process more and more effective, because it is going to please your customer. It is going to satisfy your customer. What you call it as the quality, right? And similarly, waste reduction. If you keep on reducing the waste, it will improve your operational efficiency, right? Because you are eliminating all forms of waste. Even thinking in a wrong way, wrong direction is also a waste, right? That is the deeper understanding of lean. So lean is not just excess items or excess machineries or excess manpower. Anything in excess is considered waste. Lean calls it as muda. So you reduce the waste to become super efficient. Reduce the defect to become super effective. Super effective means defect-free products. The products are best in class, right? Similarly, super efficient means your operational efficiency is very high, which means your manufacturing cost of offering a service is very low. So doing it together will satisfy the customer, will also satisfy the business, right? The quality will be at its best. At the same time, your profit margin will be very high. This is the main reason companies, are running towards Lean Six Sigma, right? That's what we have understood. And we also learned a little statistics, right? Average and standard deviation. Average will tell you the central tendency in your process. What is that your process is targeting? How do you know? You collect data from the process, calculate the central tendency. It can be mean, median, or mode, depending on the type of data, right? Most of the time it is mean or the average. So average will tell you what is that your process is actually targeting. And the customer will have a target in mind. If what your process is targeting and what your customer is targeting, it is very important that it should sync, isn't it? What your process is targeting and what your customer is targeting, if both of them are syncing, that creates a best scenario in any business. That's why we should always aim to have our process average right on the target. If our process average is not on the target, if it is shifted, we must immediately understand that our process is off targeted. Why our process off targeted? It is designed badly. Whether the process is designed correctly or not, you can understand just by looking at a single statistical measure called average or mean. On the other hand, the consistency in your results should also be checked. My process is targeting well. If I run the process several times, will it satisfy every time my customer's requirement? Will it give me the same targeted result every time? And in order to understand that, you should also calculate one more statistical measure called standard deviation. So what is standard deviation? The deviation from the center. Center is on the target, and now your data points are deviating from the center, which means it is more likely that your data points, your products are also going to deviate from the customer target, right? So you should also keep an eye on the standard deviation. Your goal should be, standard deviation should be as low as possible. If standard deviation is low, your points are not deviating from the center. Your points are not deviating from the center. And where is your center? Your center is on the target. This is how we control our outputs no, conceptually. And now what kind of metric data you are collecting, and the average of it will represent how capable your process is. And the standard deviation of your data points will represent how consistent your results are. We want consistent results. We want consistently great results. Whether you are consistent or not, standard deviation will speak about it. Whether you are consistently great or not, central tendency will speak about it, right? And if the central tendency as well as standard deviation are in your favor, I mean central tendency is on the target, standard deviation is very low, that means you are going to be consistently great. That's how your business process assures you, sustainable results. Sustainable results, predict your process becomes predictable, isn't it? Because what is happening today and what is happening, last 3 months or 6 months, using which you should be able to predict what is going to happen for the next 6 months, and then only you can take important decision. So that's why we learned some statistics also, right? And also the define phase, we understood that we have to present our project in a in a way that any top management will be interested to approve it, isn't it? So we always see to that we propose the project with appropriate business case. Doing a project, yes, resource budget is required. If budget is required and we are going to provide you the budget, what is that the company is going to get back? That's called a business case. Mathematically, we call it as is that variable, right? And how do we achieve the business case? By improvising the features in our product, right? Certain features are responsible for the customer satisfaction, and if those features are not up to the mark, we will actually improvise them. So those features which will satisfy our customers are called as the Y variable. We have also given a special name called CTQ, critical to quality characteristics, right? We improve the critical to quality characteristics, thereby the business results will improve, because improving the CTQs will improve the customer satisfaction. So your customer retention becomes easier and creating new customers also becomes easier. That's how your business results improve. So in order to improve the Z, we keep an eye on the Y and we continuously improve the Y so that our Z will also continuously improve. And we know CTQs depends on other factors in Six Sigma, isn't it? So in order to improve the Y, we will figure out the X factors, we'll identify the critical X factor and optimize the critical X factor, thereby the critical Y will get optimized. So identifying the CTQ, creating a complete plan of execution, the project proposal is the main activity in the define phase, and the main deliverable from the define phase is an approved project charter. An approved project charter along with a high level process map. So once these two documents are ready with you, it simply means you have completed the define phase, because you identify the CTQs, you also presented it nicely along with the very good business case, and you ensured the project goal alignment. Project has got a goal, your organization has got a goal, and if these two goals align, then your project will definitely be considered and given preference. And then you created the proposal, project charter, and then it is approved by the project sponsor. And now you move on to the next phase. What is the next phase? Measure phase. Now our goal is to measure the ground reality correctly, accurately, right? What is actually happening in my company? What is actually happening in my business process? So far, we are a little subjective. We took the information, opinions, and all available information without any suspicion. We considered them as true, and then we prepared the project charter. And now we are going to verify all of them. That's where we have the measure phase. We are going to collect data and we are going to understand the ground reality. Ground reality is called baseline performance. So main goal of the measure phase is to understand measure the baseline performance correctly, accurately, right? And always when we collect data, we learned that data comes with the error, and error can be of two types. One is bias, another one is inconsistency in the data. You can, and we consider or we validate the measurement system using two measures. One is accuracy measures, another one is precision measures. We need accurate readings. We also need precise readings. What is accuracy? Closeness to the true value. Accuracy means closeness to the true value. Precision means consistency. I want to be accurate and I want to be consistent, which means I want to be consistently accurate. So how do you know whether your readings are accurate? How do you know whether your readings are precise? Sometimes what happens, even a small error that your team might commit in the measurement can create the heated arguments between you and your customers. Right? You might say the product is good and your customer still might say the product is bad. Why is it happening? Definitely one of you is wrong, right? Because a same product cannot be good, good as well as bad. Either it should be good or it should be bad. But why there is a difference of opinion? Someone is, measuring wrongly. So in order to prevent this, we must try to eliminate the error. Trust me, eliminating the error is not possible. You can only target to reduce the error. You can only target to control the error within limits. The industry standard is measurement error can be 10% of your working range. Measurement error can be only 10% of the working range. So what is a working range? What could be your lowest data point? What could be your, the highest data point? And this will give you the range. Out of this range, 10% of it you can accumulate in the form of error. So how to measure the measurement error? We have taught you certain metrics. One is bias. If bias is a measure of inaccuracy. Bias is a measure of inaccuracy. What we want accuracy. If we want accuracy, then bias should be 0. If we want accuracy, bias should be 0. And so we measure bias. And also we expect the bias to be constant. We actually expect the bias to be 0, but it is difficult because we continuously use the measurement system. So there could be wear and tear and people may violate the procedure and environment can disturb, and all these things can definitely, bring error in your data, can make your reading inaccurate. But bias needs to be minimum, and most importantly, bias needs to be constant. Bias is 0, that creates a very, very healthy scenario. But if it is not 0, if it is a small value, it should be at least constant. Why it should be constant? If it is constant, you can adjust your readings according to the constant and still make your readings accurate. It is something like, finding out the time from our wristwatch. If our wristwatch is 10 minutes faster, at any instant of time, you can get the correct time, isn't it? Because it is 10 minutes faster. So whatever time it shows, you subtract 10 and thereby you get the correct time, isn't it? Same way, your measurement system, even if it gives a reading with the bias, you can still correct it and make your readings accurate by adjusting the bias. This process is called calibration. This process is called calibration, and by calibrating your equipment and by increasing the frequency of calibration, you can maintain your bias constant over a longer period of time. If you can maintain your bias constant over a longer period of time, that's called stability. That's called stability. Stability means bias is constant over a longer period of time. Your project is going to be, for a period of 3 to 6 months. And from day 1 till the last day, the bias is maintained to be 0.005. Yes, you have maintained your equipment so beautifully that the bias is always constant throughout the project. That means your readings are stable readings. Similarly, another requirement is bias should be constant over the range of the reading. The lowest value, highest value. It could be anything. It could be diameter, it could be customer satisfaction score, or it could be surface finish, or it could be the turnaround time of process, whatever it is. Always, there will be a lower value, there will be a higher value. How much bias your measurement system is giving at a lower value? How much bias your measurement system is giving at a higher value? it is expected that bias is constant throughout the range. It is expected that bias is constant throughout the range. Only when the bias is stable, only when the bias is, linear. Linear means constant over the range. Stable means constant over time. Linear means constant over the range. Only when the bias is constant over range and over time, calibration procedure can be arrived and equipment can be calibrated. Otherwise, even after calibration, your equipment will give readings with bias, right? So these are the requirements to improve the accuracy of your measurement system and minimize the bias. That is one aspect. What is the other aspect? Precision. And that is what I'm going to take you through today now. So precision means the consistency in the reading. So consistency can be a problem, right? I have an equipment. I have the equipment with zero bias or low bias. Now my goal is I should ensure consistency, right? I might have 2 to 3 people collecting data for me. Since there are 2 to 3 people, each person can collect data, in a specific way. There is a possibility, though SOP and everything is available, there is a possibility that people can, slightly deviate from the procedure. And so for the same product, different people can give me different reading. If different people give me different reading, now it leads to inconsistency. Your readings, will have precision error. What we require is, we not only require accurate reading, we also require precise reading. So accuracy, we measure through bias, and precision we will measure through 2 important measures called repeatability error and reproducibility error. That is what we are going to learn now in the first session today. So ultimately, if you sum up all the measurement error, it should be less than 10%. That is the goal, right? So shall we move on to the presentation mode to understand